Hello class, I'm Victor Sierra with the Backyard Engineers Group, and this is our Project One presentation.
Hello, I'm Alyssa, and for our project, we analyzed the Hayes Street Bridge and whether it can or cannot handle vehicle traffic. We believe that it can be a good use for transportation, especially in the busy downtown area. A scale model of the truss was examined, and the highest force or maximum load of the beam was calculated. So here we have an actual image of the bridge, and next to it is its Pratt truss free body diagram with the pin and roller and over a span of 40 meters. So um, in this, we have the truss in which we put in the software, and next we solved for one of the joints.
Hi, I'm Julianne, and as Alyssa mentioned, we recreated the truss within the stress simulator. I attempted to get this simulation as close to scale as I could, then added 3 points of force of 100 on joints 2, 4, and 6, where traffic would pass over. We can see with the simulation solved that the force is evenly distributed and no members or joints failed.
Hi, my name is Omar Hassoun, and I solved for joint 7. Um, what I did is I took the tan inverse of the joint 7 over 6, and I got 49.40, and then I solved for the sum of force x, which is the joint 7, and then I did the same for the sum of xy, solved for the joint 6 as well. I got equal to 0 newtons for both.
In the prototype of the bridge, its strength was being tested with weight that was added, and it eventually collapsed.
Hello, this is Victor again. The following illustration represents a free body diagram of an I-beam from the truss. The diagram illustrates how the I-beam reacts to external forces based on the following dimensions. The flange thickness of 2.2098 centimeters and the flange width of 18.4023 centimeters, with the web thickness being 1.8923 centimeters. When an external force is applied, this causes an internal shear force at the I-beam cross-section. This causes compressive and tensile forces, which result in a bending moment. And depending how the I-beam is supported and the reaction forces, this can cause positive sagging moments or negative hogging moments.
So in these calculations, we used and assumed the standard steel beam sizes, which gave us our moment of inertia. We input our information into a calculator, then found the PCR. We multiplied the PCR by the cross-sectional area, and it gave us the critical load of 3.68 times 10 to the power of 7 newtons centimeters squared. We then divided our critical load by a safety factor of 2, which gave us a max load of 1.84 times 10 to the power of 7 Newton centimeter squared.
Hello, I'm Zephin. The Hay Street Bridge will be analyzed if whether or not it can handle vehicle traffic and be of good use for transportation through the downtown area. Scale model of the Hay Street Bridge was made, and the highest force the beam can handle was determined to be 1.81 times 10 to the 7th power Newton centimeters squared. It was concluded that the truss cannot handle vehicle traffic due to the column buckling from its calculated maximum load. It's important that we went ahead and had a trial run with the truss design because since it collapsed, it shows that it was unsafe to be constructed for an actual bridge. And safety is the number one priority. So seeing that the truss failed would help us to construct a better, more stable truss that is safe for everyone to use. And then this is our references.